The flood of robocalls you are fighting right now is not a software bug, nor is it simply a failure of regulation. It is an economic inevitability driven by the collapse of marginal compute costs. For decades, attackers were limited to static scripts because generating unique conversations was too expensive and slow. Today, generative inference allows bad actors to run millions of dynamic, adaptive conversations simultaneously on consumer-grade or cloud GPUs with near zero cost per interaction. This shift has turned spam into an industrial-scale attack vector where the economics favor the attacker so heavily that traditional defenses are now obsolete. To understand why your phone keeps ringing despite every block list you have ever used, we must look at how the underlying technology of these calls changed fundamentally. The problem is no longer about blocking a specific file or recording. It is about a transition from storage-based spam to compute-based spam. In the past, if an attacker wanted to call 10,000 people with different stories, they needed 10,000 pre-recorded files and human operators to manage them. That was linear scaling. More calls meant exponentially higher costs in time and money. Modern generative models have decoupled volume from cost entirely. Instead of playing a recording that loops the same 30 seconds over and over, an AI model can now listen to your voice in real time, understand what you say, and generate a unique response tailored specifically to your reaction. This capability is known as information generation combined with synthesis. It allows the caller to adapt instantly if you ask for more details or try to hang up. The result is a conversation that feels human, yet costs the attacker fractions of a cent per interaction, because modern inference hardware makes running these models incredibly efficient at scale. This economic asymmetry explains why defenses are failing when they used to work. For years, systems relied on STR and shaken authentication protocols. These act as digital ID cards for phone calls, verifying that the caller is who they claim to be. Technically, this system works perfectly well in isolation. However, it fails against adaptive resilience because attackers have learned to use dynamic inference to bypass filters that rely on recognizing predefined scripts or static patterns. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. When a scammer uses an older method, their voice print and script are fixed. The network can flag them as soon as they match a known bad pattern. But with generative AI, every call is unique. A single model instance can generate millions of distinct conversation flows without needing new files to be uploaded or stored. This means that even if you block one specific number or voice print, the attacker simply spins up another instance on their cloud infrastructure and tries again immediately. The system remains broken because attackers can scale inference at volume faster than regulatory bodies or technical countermeasures can update their rules. The data supports this view of a massive shift in capability. Analysis spanning over 5 years and covering 3 million voice calls shows that while unsolicited call volumes show some decline in specific metrics, the persistence is driven by high complaint rates and fraud extraction. The system does not break because the technology fails. It breaks because the cost to defend against dynamic inference has outpaced the ability of legacy systems to adapt. Attackers have successfully adapted to mandatory authentication protocols by leveraging generative AI for real-time conversation rather than relying on static scripts that are easily blocked. For developers and engineers, this creates a new class of system design challenge. The problem is no longer, how do we block this specific script? It has become a fundamental question regarding cost asymmetry. Defenses that rely on pattern matching or static signatures are obsolete against dynamic inference. Engineering effort must shift toward behavioral analysis, cost-based rate limiting at the API level, and detecting anomalies in conversation flow rather than content keywords. We need to build systems that can identify when a voice response is generated by an AI model designed for fraud, not just when it matches a known bad actor's profile. The human element also plays a critical role in why these attacks are so effective. Research into how people interact with predictive authority shows a striking trend. In studies where participants believed they were interacting with an AI that had high predictive power, the odds of foregoing a guaranteed reward increased by a factor of 3.39 compared to random framing. Over 40% of study participants treated the artificial intelligence as a legitimate authoritative source, leading to earnings reductions ranging from 10.7% up to nearly 43% in some conditions. This psychological vulnerability is weaponized when scammers use generative models that sound confident and knowledgeable, bypassing our natural skepticism because the machine sounds like it knows exactly what we are thinking. The hardware reality behind this shift cannot be overstated. What used to require a dedicated server farm or expensive specialized equipment can now run on consumer-grade GPUs or standard cloud instances. This democratization of inference means that anyone with enough compute budget, which is often negligible for these attacks, can deploy thousands of simultaneous call agents. The cost per interaction drops so low that the attack becomes profitable even if only 1% of victims fall for it. It is an industrial-scale operation where the attacker pays fractions of a cent to try again on every single number in their list until they find someone who answers and believes them. Until we solve the fundamental economics of inference or implement behavioral AI detectors, this will remain an arms race where attackers have the distinct advantage of near-zero marginal cost per victim interaction. We are seeing a future where spam is not just annoying noise, but a sophisticated application of generative intelligence designed to extract value through deception at scale. The solution lies in understanding that we are fighting against cheap compute power, and our defenses must evolve from blocking static files to analyzing the dynamic behavior of real-time conversation flows. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.